So now we can see that the atomic packing fraction for a face-centered cubic unit cell is given by blah 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 blah. However, in the case of a body-centered unit cell which has two whole atoms, the atomic packing fraction blah 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 blah.
I didn't get any of that. Yeah, I really don't understand.
I don't understand any of that. Like the whole body centered.
What's that? Guys, I found this video explaining it.
So, what is a unit cell? Crystals are formed from a repeating structure we call the unit cell. We can visualize this by drawing a grid of atoms. There is a clear pattern, and the unit cell is the smallest repeating unit in that structure. In 3 dimensions, unit cells are described by the lengths of the sides and their internal angles. Cubic cells have equal side lengths and equal internal angles. Orthorhombic have equal angles but different lengths, and there are other types with differing internal angles. However, today we will focus on cubic.
So what is a packing fraction? An atomic packing fraction is the proportion of volume of a unit cell that is occupied by the crystal's atoms. Mathematically, this is given as Na times Va over Vu, where Na is the number of atoms in a unit cell, Va is the volume of an atom, and Vu is the volume of the unit cell. Here's an example of calculating the atomic packing fraction for a simple cubic structure. The number of atoms is 1, since each corner contributes an eighth of an atom in the unit cell. Expanding the atoms and looking at one face, we see that for a unit cell of side A, 2r equals A, so the radius is A over 2. Now we can calculate the volume of a sphere, and using the volume of a cube for Vu, we can substitute these values into the formula for the packing fraction, which simplifies to 0.52.
Right, so for a face-centered cubic structure, the total number of atoms is 4, as each of the 8 corners contribute to 1/8 of an atom and each pair of faces contribute to half of an atom. Let's denote the side lengths of the cubic unit cell to be A. Visually, it can be seen that this is equal to 2 atomic radii, whereas 4 atomic radii make up the diagonal. The packing fraction of an FCC unit cell is always the same regardless of these lengths, as you will come to learn. The value of the first parameter in our APF equation is 4. Since the atoms are spherical balls, their volume is given by 4 over 3 pi r cubed, and the unit cell has a cubic volume of A cubed. Again, we write r in terms of A, so we resort to Pythagoras' theorem. A and B are both lengths equal to A, so we have 2a squared is equal to 4r squared, as the hypotenuse of the right-angled triangle is equal to 4r. With a little bit of rearrangement, we see that r is equal to the square root of 1 over 8 multiplied by A. Now the APF is such that the A cubed from the numerator and denominator cancel each other, leaving us an equation with all constants, equating to 0.74, which is the atomic packing fraction of a face-centered cubic structure.
Formula as before. Let's finally look at the body-centered cube. Each green point here represents the center of an atom. With 1/8 of an atom being added in each corner, and 1 in the center, we have here n equals 2. Next, let's work out the brown diagonal length of one of our outer surfaces, here labelled B. From Pythagoras, we can quickly see that B equals root 2a. To work out the green central diagonal line labelled C, as this is where the atoms form a solid line. With the length B forming one side of the triangle, and the side of the cube A forming the other, we can use Pythagoras to quickly see that C equals root 3a. The length C goes from the center of one corner atom, entirely across the central atom, to finally reach the center of the other corner atom. This means that C is 4 times the length of the radius of an atom. We can equate this to our early value of C to get R in terms of A, and allow us to sub it into our final equation to give the atomic packing fraction of 0.68.
Thank you. You're welcome.